Ladies and gentlemen, please be seated. Ladies and gentlemen, with a round of applause, please join me in welcoming our guest of honor, Minister of State, Mr. Alvin Tan. Good morning, guest of honor, Minister of State, Mr. Alvin Tan, His Excellency Dr. Norbert Riedel, Ambassador of the German Embassy in Singapore, Mr. Christoph Hallier, Deputy Head of Mission, German Embassy in Singapore, Mr. Andres Ora, First Secretary and Deputy Head of Mission at the Royal Norwegian Embassy in Singapore, distinguished guests, partners, ladies and gentlemen. A very warm welcome to the 12th edition of NAMIC's Global Additive Manufacturing Summit. My name is Lorene and I will be your MC for today. The 12th Global AM Summit is part of the AM Week, a week-long series of AM activities including startup pitching sessions, workshops, lab tours, and showcases. And the Global AM Summit will mark the end of this week on a high note. Now this year, we have gathered industry leaders and experts in the AM space to share their insights around our theme, enabling sustainability and supply chain resilience with additive manufacturing. With our lineup of speakers spanning across the industries and our three very interesting subtopics of cellular agriculture, sustainable urban solutions, and renewables and environment, I'm sure we'll all gain fresh insights on the growing AM sector. So without further ado, I'd like to invite the CEO of NAMIC, Dr. Ho Chor Sing, up on stage to give the welcome address. Dr. Ho, please.
Mr. Alvin Tan, Minister of State, Ministry of Culture, Community and Youth, and Ministry of Trade and Industry, His Excellency Dr. Norbert Riedel, Ambassador, German Embassy, Singapore, distinguished guest speakers, friends, and colleagues. Ladies and gentlemen, a very good morning and a very warm welcome to all of you. This summit is our 12th user-focused Global Additive Manufacturing Expert Forum and rounds up a remarkable and eventful Singapore AM Week. This year's theme, Enabling Sustainability and Supply Chain Resilience with additive manufacturing, is an apt and timely one given the evolving global geopolitical market landscape and climate urgency. We are very pleased to have this strong partnership and support from various partners for this Singapore AM Week. And I will list out the partners in no particular order: Extra Bold, Hexagon, HP, Formlabs, Autodesk, Proterial, I2I, IVTech, Hyperganic, and Dassault Systems. I would also like to give a shout out to our colleagues from the Maritime Port Authority of Singapore, A-Star, Enterprise Singapore, Singapore Design Council, Economic Development Board, SG Innovate, and Simtech. Without their support, it wouldn't have been possible to put together this wonderful itinerary of events, featuring the latest technological progress and applications in additive manufacturing, such as the 1 kg challenge, the expert panel sessions and the roundtables, design workshops, and center tours. Our special mention is the 1 kg challenge, a public competition held for the first time outside of Japan in partnership with Extra Bowl. Participants were challenged to develop a 1 kg 3D printable design model showcasing sustainability and innovation. Shortlisted designs were 3D printed for a design exhibition during the Singapore Design Week, which is ongoing right now. And the top winners of this year's competition actually is a student from Raffles Institution, as well as a couple of professional designers and engineers. The exhibition is still ongoing, held at the Visual Arts Center beside Dhoby Ghaut MRT station, and it's open to public for free. So please do drop by to view the exhibits before we close, end of this Sunday. Early on Wednesday, we also featured exciting pitches from shortlisted global and Singapore-based deep tech additive manufacturing startups spanning across various industry verticals in AM technology, robotics, sustainability, healthcare, and food tech, among others. In its 4th edition, the NAMIC Startup Innovation Forum is the leading additive manufacturing startup pitching event in Southeast Asia, with the goal to identify, nurture, and catalyze the growth of AM deep tech startups in Singapore and beyond. This year's winners are Frontier Bio, a US-based life science tissue engineering bioprinting company focused on the disruption of animal testing and reducing patient mortality rates by using cutting-edge 3D bioprinting and organ-on-chip technology. Eric Bannert is here today with us. He will, in fact, give a talk later in the first session. Centera is the other winner, is a Singapore advanced manufacturing materials company using their own proprietary AI platform design factory, which is trademarked. And it enables rapid discovery and development of new materials with sustainability in mind. The third winner is Lifespence. It's a Hong Kong, Singapore-based medtech startup providing medical implant testing services that uses proprietary particle-based bone tissue and foam software models to get simulation results up to 10 times faster than the traditional testing labs. To round up the week, and today we are very honored to have this Global M Summit. We have 15 global thought leaders and media partners with us. Divergent 3D, Frontier Bio, Cosmo Health, Stakeholders Food, Umami Bioworks, Innovate 360, Smart Tech, TCT Group, Satim MacCore, TAE Technologies, Coolest DC, Miniwiz, Witten Bean Boss, Cobalt, and Type 0 Architecture. All of them have been selected based on the work they have been doing, pioneering in the space of design, advanced materials, built environment, environmental tech, clean energy, cellular agriculture, bioprinting, and supercars. Despite the growing geopolitical and technology bifurcation, there is no doubt that we all live in a global village with complex interdependencies among nations and people. Sustainability in development and manufacturing is a common humanity goal that we all need to embrace and work together to achieve. Our vision for the future is a sustainable, net, carbon-neutral world with nature-inspired biomimicry products and solutions enabled by on-demand distributed manufacturing with recycled or sustainably sourced materials. Design thinking combined with design for additive manufacturing can lead to outcomes and solutions that are innovative and human-centric, leading to more sustainable products and solutions. Businesses, whether in consumer, in healthcare, or industrial, or even some of the new emerging spaces, will need to stay adaptable and nimble through the adoption of these new technologies and to reskill talent pool. Exponential technologies such as robotics, artificial intelligence, and additive manufacturing will play a pivotal role in enabling some of the new paradigms in the future of production, such as in distributed manufacturing. The ability to harness end-of-life recycled materials as manufacturing feedstock, optimize product designs through fast iterative cycles of design and simulation with minimal material waste, and on-demand manufacturing, other benefits such as lightweighting and part consolidation, all have this great potential to transform our future for the better, resulting in more efficient supply chains and lowering carbon footprints. And we aspire to empower our current and next generation of engineers with the tools and technology of which additive manufacturing is central to solve the increasingly complex problems in the world. On this note, I would like to take this opportunity to thank all our speakers who have taken valuable time out of their busy schedule to prepare and speak at this event, several of whom actually have flown into Singapore just for this. So very thankful for that. We're on this journey together, and we'll need all of you to work with us and pave the way. Finally, I want to thank my wonderful team behind this event, together with our colleagues from A-Star, partners from Advocate and Associates, Sullivan, as well as Constella, who have supported us and worked tirelessly to put all this together. Also like to make a special mention of our university, polytechnics, and A-Star cluster teams who have worked together in the last few months to put together this whole week of itinerary of events. And I encourage all of you to reach out to the speakers and fellow participants and hope that you will benefit from the content we've put together. On this note, I wish you all a very fruitful and productive summit ahead. Please enjoy the show. Thank you very much.
Thank you, Dr. Ho. And indeed, to echo what Dr. Ho has said, thank you very much for joining us today. I hope the coffee makes up for it. And of course, today we are very honored to be joined by our Minister of State, Mr. Alvin Tan. So to officially kickstart GAMS 2023, I'd like to invite Minister up on stage to give the opening address. Minister, please.
Good morning, everyone. Good morning, Dr. Ho Chow Sing, CEO of NAMIC, my friend, Ambassador Norbert Riedel, and also to many of our guests who, as Dr. Ho Chow Sing mentioned earlier on, have traveled from afar to come to GAMS 2023. It's a warm welcome to Singapore. It's a bit warmer than usual, and that's why we have some focus on sustainability as well. I was at the summit in 2021, Dr. Ho reminded me, but we did it virtually. So it was almost a world away during the COVID crisis. But now I think we're back, and it's really good to be able to have this iteration in person. At the summit in 2021, I spoke about how our additive manufacturing sector has grown over the past decade and significantly over a very short span of time. 2 years later, we continue to see a very strong growth trajectory. Let me put that now in figures. There are over about 200 companies that have adopted AM in their business processes just in Singapore today. And there's a 30% increase compared to about 2 years ago. In Southeast Asia alone, AM is expected to generate about $100 billion in economic value by 2025, and Singapore has a 40% share in this market. Now, AM, as it were, as I frame my speech today, I will talk about how AM is a key to unlocking 3 doors. This year's summit theme focuses on sustainability and supply chain resilience with additive manufacturing. So sustainability as well as supply chain resilience are these first 2 doors. Let me begin with the first door that additive manufacturing can unlock. And that first door is sustainability. Investors and consumers now, across various sectors, now demand businesses or expect businesses to be more sustainable. And additive manufacturing, I believe, can meet these demands. By using more sustainable materials or by recycling, AM can promote circularity and also reduce waste. For example, the National Technological University, or NTU's, Singapore's Centre for 3D Printing collaborated with local companies to research the use of recycled materials like glass, rubber, and incinerated ash in the building and construction industry. Last year, they 3D printed a bench out of concrete and recycled glass and are now commercializing as well as scaling up their technology. Homegrown SME Mancast Marine also collaborated with NAMIC to 3D print a copper-based ship propeller in lieu of its traditional casting methods. Mancast Marine now has a greener product line and a more sustainable approach towards manufacturing. Later on, we'll witness an MOU signing between Alstom, a pioneer of sustainable rail solutions, NAMIC, and our Land Transport Authority here in Singapore. Their joint industry program will see the use of recycled materials for rail repairment and rail refurbishment and the additive manufacturing of rail parts that will reduce the carbon footprint for transport as well as for warehousing. So I think we're really encouraged that many of these companies are taking that first step and hope to see more companies adopt more AM and use this additive manufacturing key to unlock all of your sustainability journeys. So that is the first door, sustainability. The second door that we believe AM can unlock is on supply chain resilience. As many of you know, or many of our guests may be aware of, Singapore is a very globally connected economy with very limited, some say even no natural resources. So we are naturally vulnerable to external shocks and supply disruptions. So AM allows our companies to then create more products locally and then makes them less vulnerable to these shocks that I just mentioned. And this is especially relevant to our healthcare sector. 3 years ago, our AM community helped mitigate supply chain disruptions due to the COVID-19 pandemic. They ramped up the production of essential medical supplies, including Singapore's own 3D printed nasal swabs. We remember that quite painfully. Today, AM allows Singapore to produce an even wider range of medical products locally that can be better customized to our needs. Zeta is a California-based medical 3D printing company that set up a facility in Singapore with the support of NAMIC as well as our Economic Development Board. They catalyze new research and development efforts for other locally 3D printed medical implants. Last year, they partnered 3 local healthcare institutions to develop medical implants for musculoskeletal and orthopedic applications. They are also now working with Tan Tock Seng Hospital to develop advanced patient-specific implant solutions. Let me cite another good example, this time a homegrown example, Osteopore, whose 3D printed bioresorbable implants have been used by over 80,000 patients globally. Today, we will also witness 2 more collaborations. These will strengthen our supply chain resilience in 2 other critical sectors, the aviation sector as well as the maritime sector. For aviation, SIA Engineering Company will work with NAMIC on spare part digitalization and on-demand additive manufacturing. For maritime, our Maritime Port Authority of Singapore will collaborate with NAMIC and the Singapore Shipping Association to connect a digital inventory and a network of qualified suppliers to facilitate on-demand supply of parts. These collaborations show the strong partnership between our public-private to achieve very meaningful and hopefully impactful outcomes. Through NAMIC, we hope to foster even more of these partnerships to advance our AM and translate research into commercial outcomes. So I've talked about the first 2 doors that AM can unlock, and now we'll go into the final door, which additive manufacturing can unlock. And that third door is innovation. And of course, innovation applies to a wide range of sectors, including more unique ones, like cellular agriculture, which we talked about earlier on before walking in. Stakeholder Foods is with us today. It's an Israel-based startup specializing in printing 3D steaks and other cell-based meats. I can't imagine steaks being flat, but I think 3D would be more palatable. We also have homegrown startup Cosmos Health, we also talked about that earlier on, which developed the world's only plant protein composite bio-ink and also a bioscaffold, and the world's only plant protein composite 3D bioprinting facility with the support of both NUS Enterprise, NAMIC, and Enterprise Singapore as well. They are working on bioscaffold solutions which are critical for cellular agriculture, biotechnology, and pharmaceutical applications development. Now, startups like Cosmos Health and Stakeholder Foods play an important role in this wide ecosystem that we're building here in Singapore, which is connected to the world. And NAMIC has also supported over 150 local and international startups like them, since 2015. Singapore is now home to over 40 AM startups, and I commit to you that we will continue to help these companies innovate as well as expand. Now, NAMIC also funds proof of concept and technology translation projects in areas such as digital workflows and functional materials in a bid to encourage innovation. These help companies adopt AM to pivot into high-value added activities as well as to constantly innovate their products and services. But if you're a company that have yet to adopt AM, don't worry, you're not left out. Next year, NAMIC will launch the Digital Design Innovation Center to help companies to select parts, design and support digital inventory development to kickstart your additive manufacturing journey. The center will also launch an academy to help with skills, training, apprenticeship, as well as accreditation. So today, in closing, I spoke about the 3 doors that additive manufacturing can unlock. We talked about sustainability, we talked about supply chain resilience, and we talked about innovation. And I believe there are even more doors for all of us to continually to unlock as we take hold of this key. I believe we can then create more solutions, attract more companies, impact other sectors, and unlock the many other doors that we will find alongside our journey. So thank you for coming, and I wish all of you a very fruitful summit ahead. Thank you.
Thank you, Minister. Please remain on stage. All right, as Minister has mentioned, sustainability, supply chain resilience, and innovation are 3 gateways that AM has paved road for. And in NAMIC, we strive to accelerate that journey. And as such, we are happy to announce 5 partnerships of 2 launches and 3 MOUs today that will do just that. Now, firstly, we would like to announce the launch of the joint venture between ThyssenKrupp and Wilhelmsen Ship Service. And to officiate this launch with a ribbon-cutting ceremony, we would like to invite up on stage His Excellency Dr. Norbert Riedel, Ambassador of the German Embassy to Singapore, Mr. Christoph Hallier, Deputy Head of Mission of the German Embassy in Singapore, Mr. Andres Ora, First Secretary and Deputy Head of Mission, Royal Norwegian Embassy in Singapore, Mr. Frederick Chu, Chief Executive of A-STAR, Mr. Kenneth Lim, Assistant Chief Executive of the Maritime and Port Authority of Singapore, Dr. Ho Chua Singh, CEO of NAMIC, Mr. Shalan Andre Engine, CEO and President of Wilhelmsen Ship Services and Director at Pelagus 3D, Dr. Chetan Nazikal, Chief Transformation Officer at ThyssenKrupp and Director at Pelagus 3D, Dr. Sebastian Smerit, Head of Customer Innovation Tribe and COO of Digital Services at ThyssenKrupp Material Services and Director at Pelagus 3D. Mr. Nakul Malhotra, Vice President, Emerging Opportunities Portfolio at Wilhelmsen Ship Service and Director at Pelagus 3D. Mr. Ken Lip Ong, CEO of Pelagus 3D. And last but not least, Mr. Hakan Ilekja, Chief Commercial Officer at Pelagus 3D. Alright, and our gentlemen now will hand out the scissors for the ribbon cutting ceremony. Please be careful. Alright, everyone has the scissors now. So, gentlemen, can I please invite all of you to take a step up? Hold the ribbon ball with one of your hands and the scissors in the other. Do not cut first. We have a very important thing to do. Look up and smile at our photographer. The flash just keeps going off. Alright, wonderful. So, we'll be counting down from 3. And we'll cut the ribbons to signify the launch of this partnership. And I need all your help, ladies and gentlemen. Please join me in the countdown. 3, 2, 1. Congratulations on the launch of the joint venture, ladies and gentlemen. Round of applause. Can we'll invite our guests to take a picture as well. Now, this venture will combine Williamson's expertise in offshore and civil maritime and ThyssenKrupp's engineering expertise in AM to develop a platform that will allow greater ease and efficiency in procurement. Okay? Thank you, gentlemen. Please take a seat. Sirs, this way, please. And of course, to mark today's momentous occasion, I'd like to now hand over the time to the CEO of Pelagus 3D, Ken Lip, to say a few words. Over to you.
Minister of State, Alvin Tan, His Excellency Dr. Norbert Riedel, Deputy Head of Mission for Germany, Christopher Hallier, Deputy Head of Mission for Norway, Andreas Ore. Ladies and gentlemen, good morning. This is supposed to be a launch event, but after greeting all the VIPs in this attendance, I really feel like this is more like an IPO event, you know. There's a lot of people, I just need the bell and the hammer, and I think we're good to go. So today I'm very pleased to be launching, as a group today, right, Pelagus 3D at the Global Additive Manufacturing Summit. In Latin, Pelagus means the open sea. Hence, it is very fitting for the company to be based in Singapore, since the old name of Singapore, Temasek, means sea town. And aptly for us, our offices downtown also has a view of the sea. But actually, when I spoke to one of the board members, he mentioned that we actually should be more in a garage with no view. Right, so, we're actually a little bit more than a startup. So why name our company Pelagus? It is a reflection of our company's aspiration to innovate in the field of additive manufacturing for our customers at sea. Pelagus 3D operates the largest global commercial program, providing 3D printed parts to more than 3,000 vessels, oil and gas platforms. In addition, we also work with major OEMs. Our customers clearly see the benefit of our offerings through better performance, shorter lead times, and lower inventory costs. And I think this is what Minister of State was referring to in terms of supply chain resiliency. And we are really seeing this, and our customers are seeing this. So with our proprietary fulfillment platform, technical advisory, and fulfillment capabilities, we aim to make digital warehousing and on-demand manufacturing of spare parts a reality for our clients. Our customers, our parent companies, ThyssenKrupp and Wilhelmsen, are no strangers to the sea. Wilhelmsen is one of the world's largest maritime services providers, doing business with 50% of the global commercial fleet. ThyssenKrupp is one of the world's preeminent material manufacturers, as well as, and well known to the navies of the world for their engineering expertise. It is with their blessing and support that Pelagus is now launched out into the waves, and we thank our respective parent organizations for this. We are also very appreciative of the support from the Maritime Port Authority of Singapore, NAMIC, and A-STAR. Singapore's efficient technology and funding ecosystem has been instrumental in the establishing of Pelagus 3D. Much thanks also to the German and Norwegian business communities, without which it would have been impossible for such an international collaboration to flourish. To conclude, the sea is more than just a place, more than just water. The sea is ever-changing, hostile, and tumultuous. The sea shows no mercy to the unprepared. Yet the sea also yields out bounties and rewards to those who successfully navigate through it. Best wishes to the Pelagus team for the journey ahead. May we sail with the wind to our backs onto the sunny shores of success. Thank you for your attention.
Thank you, Ken Lip. And of course, in addition to that, riding the waves of the partnership, we are also proud to announce the launch of the Additive Innovation Center today. Previously known as the Industrial Additive Manufacturing Facility, or IAMF, the facility will now be transformed to be an AM Technology Translation Center supported by NAMIC and enable companies to adopt AM by lowering barriers to the technology. So joining us on stage for the launch, please join me in welcoming once again Minister of State, Mr. Alvin Tan, Dr. Ho Chao Sing, CEO of NAMIC, Mr. Frederick Chu, CEO of A-Star, Professor Lim King Hui, Assistant Chief Executive of SERC at A-Star, Dr. David Low, Executive Director of SimTech and CEO of ARTC, and last but not least, Dr. Sharon Nai, Hub Director at the Additive Innovation Center. Ladies and gentlemen, a round of applause. So now, firstly, before we launch the AIC, can I invite all the guests on stage to stretch out your right hands without touching the ball for a picture, please? Give your best Friday smile. All right, once again, counting down from 3. I'd like to invite everyone to count with me. We'll officiate the launch of AIC, all right? So ladies and gentlemen, 3, 2, 1. Congratulations once again. Thank you so much. May I please invite all our guests to take a seat as we will have a very special video to show everyone. Now, and truly, with the launch of AIC, we will now accelerate the transition and deployment of additive manufacturing solutions faster than ever, making the future possible today. And to commemorate the launch, I'd like to invite everyone here to join us in watching this very special video of an introduction of AIC. So please sit back, relax, and enjoy.
The Additive Innovation Center is an integrated platform for end-to-end additive manufacturing solutions. AIC was designed to be the nerve center for additive manufacturing technologies and innovations, allowing industry partners to meet up and brainstorm on problem statements that are unique to their business needs.
One of the top priorities in Singapore's Research, Innovation and Enterprise RIE 2025 plan is scaling up platforms to drive technology transformation and strengthen the innovation capabilities of our enterprises. Additive manufacturing will form the cornerstone to support a more sustainable future through circular design and cradle-to-cradle manufacturing. AIC will serve as a bridge for promising A-Star research outcomes to be accelerated for industry test bedding and commercial scale-up, drawing on the entire domain expertise from the A-Star research community.
Our collaboration with SimTech and IHPC sparked an organic fusion of each other's technology and know-how in high-performance material and advanced material processing. Together, we could achieve deliverables that exceeded our expectations and maintain high mutual motivation.
A-Star connected us to IMRI's Dr. Wang Fuke and his brilliant invention in 3D printing material technology. It is not easy for commercial companies like us to partner with a research institution because of the vastly different focus and operational methods. Overall, IMRI has been a great partner. The support from them has been amazing.
ST Engineering's significant engagement with SimTech and ARTC is to leverage SimTech and ARTC expertise and extensive resources to develop solutions to the industry's various challenges. Our common interests, trust, and value gained from collaborating with each other, as well as the strong team bonding built over the years.
Integra selected SimTech as the optimal organization for our applications, which are focused on fundamental process and materials research. SimTech's solid infrastructure and world-class scientific talent. It has resulted in important insights for current projects and has created opportunities for us to innovate together in the future. They took the lead to find alternative solutions and help to ensure continuous progress of our engagements during the unprecedented COVID crisis.
Rolls-Royce has been an anchor member with the ARTC since 2012. Our partnership is based on mutual trust between our two organizations across multiple levels. The wide range of technologies and technical capabilities within ARTC and the wider A-Star community have enabled us to work seamlessly in many cases.
With our experienced team of researchers in this field, we believe there will be a lot of value we can create jointly with our companies in this industry. We look forward to forging a stronger and highly impactful ecosystem for the AM industry.
Once again, congratulations on the launch. And now, of course, to further strengthen our capabilities in AM through partnerships, we will now have 3 MOU signings. Now, the first will be between SIA Engineering Company and NAMIC. This partnership aims to build diversity and resilience to SIAEC's supply chain by allowing digitization of spare parts and on-demand additive manufacturing. This will strengthen SIAEC's capability in aircraft cabin maintenance and materials development at industrial standards. And joining us on stage for the MOU, ladies and gentlemen, please join me in welcoming our signatories, Mr. So Man Feng David, Senior Vice President of SIAEC, and Dr. Ho Chao Sing, CEO of NAMIC. And our witnesses, Minister of State, Mr. Alvin Tan, Mr. Wong Yue Jin, Senior Vice President of SIAEC, and last but not least, Mr. Frederick Chiu, CEO of A-Star. Now I'd like to invite our signatories to sign on the MOU. And with that, congratulations on the partnership. Ladies and gentlemen, a round of applause. Thank you so much. May I please invite the gentlemen of SIAEC to take a seat, while Minister Dr. Ho and Mr. Chiu please remain on stage. All right, next up we have the MOU signing between Simtech and OMS Oilfield Services. And participating in the MOU, ladies and gentlemen, please join me in welcoming the signatories, Mr. Hao Ming Hook, Chief Executive Officer at OMS Oilfield Services, and Dr. David Loh, Executive Director of Simtech and Chief Executive Officer at ARTC. Ladies and gentlemen, a round of applause. Now, Minister Dr. Ho and Mr. Chiu will be witnessing the MOU signing. So whenever you are ready, gentlemen, please sign on the MOU. In this agreement, OMS Oilfield Services partners Simtech through AIC to scale additive manufacturing through 4 pillars, namely R&D, upskilling and training, application development and qualification. Now, OMS Oilfield Services, as the world-leading oil and gas company, will accelerate their resilience with the help of AM. So, ladies and gentlemen, another round of applause. Now, may I please invite our signatories to take a seat? Thank you very much. So I'll keep Mr. Chiu, our Minister, and Dr. Ho just for a little bit more, okay? Last but not least, we're pleased to announce the joint industry program curated by NAMIC, LTA, and Alstom. Please join me in welcoming our signatories, Mr. Chia Chun Po, Group Director, Real Assets Operations and Maintenance at LTA, Mr. Yan Maizendu, Managing Director of Alstom in Singapore and Malaysia, and Dr. Ho Chao Sing, CEO of NAMIC. Now witnessing this MOU signing, we have our Minister, Mr. Chua Chong King, Deputy Chief Executive, Infrastructure and Development at LTA, Mr. Ganesh Ramalingam, Site Managing and Customer Director at Alstom. So signatures whenever you are ready. Now, the JIP will catalyze the adoption of on-demand additive manufactured parts for trains and digital spare parts inventory in supporting more resilient and future-proof rail operations in Singapore. Another round of applause. Thank you, gentlemen. I'd like to invite. Thank you. Please take a seat. Sorry for keeping you so long on stage. Thank you. And once again, congratulations on the new launches and partnerships, and thank you once again, Minister, for joining us today. Now, being able to witness the alliances between different enterprises is truly heartening. And I'm sure with these, we are all looking forward to a very exciting future in which AM technologies will enable more innovative and sustainable solutions to current practices. Now, with that, I'd like to jump onto the first agenda of today, our keynote presentation. Now, and we are going to take a look at how we can achieve anti-fragile and sustainable vehicle architectures. And speaking to us about it, please join me in welcoming the CTO of AM Technologies of Divergent 3D, Michael Kenworthy. Michael, please.
Thank you for the kind introduction. It's a real pleasure to be here and for the first time in Singapore, and to see the incredible AM ecosystem, advanced manufacturing, technology. Everything that I've seen this week has been truly exciting. And it's a real pleasure to present my company and our team accomplishments, and to hopefully inspire and also create some new ideas out of what I share with you today. Sorry, I don't have the clicker. Is there a clicker for the presentation? Okay, Divergent Technologies, let me start by, from the beginning to introduce. Thank you. We're actually two companies, and I'm going to share a little bit about Divergent Technologies, which is the parent technology company, and what we've built. And then we also have Zinger Vehicles, which is our vehicle brand that's a subsidiary of Divergent. And some of you may have seen this hypercar that we've created using AM tools, and I think it's a really, for me personally, inspiring to see what was created with such a small team, and I think that paints the vision of the future of AM and that power of small teams. So without further ado, I'm going to just play a little intro video for getting the things started here today. Racing on Laguna Seca track. This is a famous track in California with our 3D printed hypercar. Some top line specs of the vehicle: it's about 1,400 horsepower, weighs about 1,200 kilograms, so better than 1-to-1 power to weight ratio. It was created using 3D printing at a whole system perspective, so we re-engineered everything from front bumper to rear bumper on this vehicle, including the powertrain system, leveraging all of the digital manufacturing tools available to us. Using an extremely small team, only about 30 to 40 engineers, we were able to create the world's fastest production car using the power of digital manufacturing. So this was really our technology demonstrator. We set out to really push the limits of the technology we were developing and using a hypercar as the mechanism for really pushing the boundaries of the technology, learning everything we can about the limits of extremely fast 3D printing, automated assembly, and then generating our own design tools. What was the inspiration for creating that? It was really recognition of a systemic problem in automotive manufacturing. So, a lot of auto manufacturing is based around tooling infrastructure and generating extremely high CapEx investments to make these decisions. The senior executives at these auto companies really have to have a lot of confidence when they're launching a new product and do a lot of developments to plan that. And so they end up having very long product development cycles. It doesn't look anything like a consumer electronics cycle. And what we set out to create was a rapid iterative tool that would deliver them the ability to take more risks, to have a zero CapEx opportunity where they are able to generate these innovative concepts, try them out in the field, and then to understand how the market would react to that, and then iterate to the next design. So we see this in the consumer electronics industry with less than 1 year development cycles, and we wanted to bring that kind of opportunity into automotive. The example with our car, only 30 or 40 people were able to create that entire vehicle and every subsystem within that. It's a fully homologated road legal vehicle. So, one of the things as we're engaging with these automotive OEMs is, of course, there's the strong theme of sustainability. They're looking at additive manufacturing technologies and wondering, can lasers and powders really be a solution for, our sustainability challenge that we have? And I believe the answer to that question is yes. We need to really take a completely different whole system approach to solving this problem. That's going to require us to develop new architectures and new ways of putting structures together to meet these objectives. If we just try to make a small refinement of the way we've always done it, there's too many diminishing returns at this point. We'll never actually achieve those goals that we want to accomplish together. So just to walk through the frame of the chassis of our vehicle that we created, you can see how much AM content is in the vehicle. We actually re-engineered virtually every part of the car. So over 400 AM parts are designed into this, mostly printed aluminum. And this leverages our automated assembly technology. So when you see some of the larger structures, what you're seeing there are 30 or 40 additive pieces that are coming together, being adhesive bonded in a robotic cell. And I'll walk you through that here shortly. So as we kind of fly through the different subsystems of the vehicle, you're seeing the different bumper structures, the front megastructure. We've developed aluminum alloys specifically to solve each of these application use cases within the vehicle to also meet our cost productivity objectives to bring a vehicle to market that actually could be addressable in a broad way in automotive. So real quickly, we have design, print, and assemble is the tagline of our company. And within these three verticals, we've actually had to do a tremendous amount of innovation and development. So over 600 patents are represented in the system that you saw. In the design module, we've had to create our own topology optimization software to solve the problems that we're doing. Multi-objective optimization. We don't talk about design for additive manufacturing. We talk about putting those rules into our optimization tools up front so that we inherently get AM producible structures out of the process. We also design for our automated assembly process, which means that we design and print in the features required for robotic assembly right directly into the structure. And then we are able to move to our print module where we've actually engineered our own custom using our open architecture printer. We've prepared our own scan field partitioning algorithms, our software to control the machine itself, the parameters that we're using, the materials that we're using in the printing process. All of this had to be brought together to achieve the cost productivity outcome that we did. And then we have introduced a new technology, universal fixtureless assembly, for the first time. We first did an automated assembly over 3 years ago using this approach, and it has the advantage of being able to have rapid change between any design so that we create with our system. We can go from producing a bumper structure in the morning to producing a frame to producing a drone, all within the same set of hardware with absolutely no fixture changes required. So a quick video of our assembly process will follow. So what you're seeing is a 22 robot cell that is assembling in this case, a 17-piece frame for a customer, one of our public customers, Aston Martin. And this goes into the V12 Vantage vehicle. These structures are on the road today. This is fully safety certified, validated by the OEM, printed at a cost that they can absorb into a EF segment vehicle, and then delivered to them and incorporated into their vehicle assembly line. So most people would not have expected this to have occurred already. There's a lot of small component level activities that are going on, but doing it at a large structural level really hasn't occurred up until pretty much early this year. For the first time, we delivered these and certified this product. So we're printing at industrial rates. So our perspective on 3D printing is not to attack the precision part of the problem and make these ultra very exquisite heat exchangers or these types of components for manned air flight. We're focused on really maximizing the productivity of a laser powder bed fusion process, and we've achieved print rates between 1 and 3 kilograms per hour in our proprietary aluminum alloys that we developed. So again, if you had just used a commercial off-the-shelf material and tried to use that, engineer a vehicle with that, you wouldn't have the material requirements that you needed to achieve, you wouldn't have the productivity that you wanted to achieve, and you really wouldn't have a product at the end of it. So you have to take a step back, take a look at the whole system, and then solve each of those pieces to bring it all together and have a comprehensive path forward to what you're trying to achieve. We are using the, as most people are probably aware, we're using the SLM NXG 12 laser machines, but simply going from 4 lasers to 12 lasers, you don't get a 3x improvement or 2x improvement. You actually see something like a 10 to 15x improvement when you put all of these pieces together. You use your own software, you use your own materials, and you have an open architecture solution. Another case study that I like to present is recently we've kind of moved from our initial automotive focus to drones and aerospace and defense type applications. So this was a part of our public partnership with General Atomics. These are actually their figures, not our analysis. So this is coming directly from the customer feedback. We were able to reduce the part count by a factor of 45. What we did was we basically integrated the entire fuselage of this small drone structure into 4 printed components that we then automatically assemble. So it's blurred out for ITAR reasons and data security reasons. But what we've done is we've integrated all the avionics mounting, all of the harness lines, all of the air ducting, the fuel tanks, the wing sweep mechanism, the strong back, the engine mounting, and really put all those pieces together into a design that's actually lower cost, lighter weight versus a carbon fiber baseline. We can produce a drone a day with just 2 printers. Our average prints at Divergent are less than 24 hours long for roughly 30 kilograms mass per day, per print job. So we're able to do, with just a small investment, we're able to crank out 1 drone a day. So you can imagine, this sort of scalable and modular solution is really what we'll be able to have a high impact and deliver on the kind of the key themes coming out of the Department of Defense in the U.S. is contested logistics, surge capacity, the ability to have fungible capacity and a 3D printing architecture that can actually automatically assemble anything with no tool changes is really what they're looking for. So a little bit more about our materials development. When we looked at the overall vehicle, we really see 4 primary applications in automotive. And as I mentioned earlier, we really had to go back to the beginning and say, hey, these materials that we're using really came from a different industry. They came from casting, they came from forging industries, and then we're trying to 3D print with these alloys. This is fundamentally the wrong approach. We need to design alloys that meet our application requirements that are suited to the process that we're using and can meet our cost objectives. So, designing an alloy that has incredibly high cost additives in it, like scandium, is fundamentally not the approach we're interested in. Yes, you can achieve great properties, but you really can't ever get yourself into an application and drive change in a meaningful way. So we focused on these problems, and we've actually come up with what we call a multifunctional alloy. So using the exact same powder, we're able to achieve 3 very different property objectives. And this greatly simplifies what we're doing in our production factories. We can run one powder and serve a wide array of production opportunities. And that lends to the global networked and fungible capacity theme that I was talking about earlier. So when we compare our alloy to something like a 6061 T6, which is what everyone's asking for, they're like, why can't you just print 6061 T6? And we all know, of course, that cracks. So especially when you try to print it at 1 kilogram per hour, you're just not going to get there. So you need to start over, you need to design the alloy from scratch, which is what we did. And we've achieved some really compelling properties where when I say as printed, I mean truly as printed. I don't mean a machined bar. I mean you can reach into the printer, pop that bar off the plate, put it in a tensile tester, and these are the properties you will get. This is -3 sigma. And then if you do a simple heat treatment, so you don't have to worry about distortion, when you do a complicated heat treatment with your AM parts and managing the residual stresses is a very challenging problem, as many of you are aware. We're actually able to solve that with a very simple heat treat and achieve 7075 T7 type properties with the exact same powder, just processed in a slightly different sequence. So you see a demonstration of the crash application of our alloy. So here we have some bumper that we 3D printed in the vehicle chassis that you saw earlier, and just a demonstration of the proper triaxiality behavior we're expecting to see. We have a fully integrated team, so every aspect of the testing and material development has been integrated within our system. I'm going to play the first one again if I can. I don't know if it'll cooperate. So you can see a full speed frontal crash test, and then you'll see a slow motion video of the same crash event. And if you tried to do this with something like ALSI 10mg, you would not have the proper energy absorption characteristics, or you would need a very long stroke length because of the very low strength of that material. Here we have a high strength material with very high elongation. Typically we're achieving about 25% as printed. So there's a lot of opportunity if you take that system level approach that can be exploited. And as you're thinking about all of your different applications, I'd encourage everyone to not focus on just one element of the system, but make sure that we're optimizing at a system level to have the greatest impact. And then doing those optimizations in the correct sequence will also help you. So when we think about our cost structure, by taking the system level approach, we've gone from a state where AM is considered this incredibly exquisite high cost process to one where today it's already competitive with E and F segment automotive needs. So we're able to compete directly head to head on cost with a conventionally fabricated cast extrusion based assembly from customers like Aston Martin and Mercedes-AMG, and deliver them a lower cost product that has higher performance and better quality. And this is really, a testament to, I think, the approach we've taken from the very beginning. And as a startup company, it's really difficult to take this kind of approach and convince your investors that you're taking the right approach because, they see it as too complex. You're working on too many things at once, and they see that as a risk to success. And I think a lot of that, thinking is actually what's held us back as an industry from actually having the impact we want. So we have a lot of people working on small pieces of the AM problem, and not a lot of people putting all of the pieces together to deliver a holistic solution. I would encourage bodies like this one and this AM ecosystem to really tackle the problem more holistically and less, sort of narrow-focused projects, because I think ultimately that generates a lot of the confusion in our customer base about what AM can actually accomplish for them when they see so many conflicting perspectives about whether the technology can really be production relevant anytime soon. The answer is yes, we're already in production applications and on the road. So our vision for our factory is really to deploy this regionally. We can position this in many different sites around the globe. Right now, of course, with our automotive initial focus, we're going to put that first factory in the EU and support our automotive customers there. We have a lot of growing interest with the with the aerospace and defense sector in the US, so we'll likely have a second facility there. But the vision is really to expand this globally and create this network of facilities all over the planet that can be networked and provide that fungible capacity. So we can truly enable a digital manufacturing approach where we're not constrained geographically to a casting foundry that may be located in one location. We have incredible supply chain freedom in that we're really just using machines and powders and any associated post-processing requirements we have, like our adhesives. And that just will really change the dynamics of manufacturing and revitalize what we're trying to do by having, you see so many examples, especially in the US, where like the steel belt or now the rust belt, was completely devastated by the movement of those industries to other lower cost countries. What we're envisioning is really revitalizing those locations with a permanent manufacturing capability that will be locally recycling materials and creating ever more optimized and higher performing structures locally. So how will we do this? We see a really strong analogy in the CNC industry. I think we sort of, there was a key transition where CNC went from being kind of a hobbyist tool that really only existed in the universities and they were incredibly expensive, to now you can go buy a kit and make your own CNC machine for about $100, $200 off Amazon, which is a really incredible transition. I see a very similar transition happening for AM, perhaps not quite as dramatic, but with relatively low cost and high productivity systems, the whole industry will be able to change and adapt to additive manufacturing as the key mechanism for delivering lighter weight structures, dematerializing our world instead of having so much excess mass that's fundamentally not needed because of legacy manufacturing processes. We can create a new dynamic where the focus is on dematerializing our structures, maximizing the optimization opportunities in front of us, and delivering products that fundamentally couldn't even exist previously. So one of the things that I lead at Divergent is our LCA analysis that we do for sustainability of our system. We really are working across every aspect of our manufacturing process to understand exactly where the energy is going, how can we optimize that, build a roadmap around it to look at different types of laser energy input, look at different types of material, powder sizes, how can we get the powder to absorb the energy more efficiently, managing our other utilities throughout the facility to accomplish a more efficient AM process. And when you're able to take a structure, a baseline structure that maybe weighs 30 kilograms in a traditionally fabricated way and take 20% of that mass out, even if your process is a little bit more energy intensive, we always have seen a net benefit from a sustainability perspective in those larger AM structures. So this is not something that if you look on a component by component level, you really have to, I think you really have to struggle to find those cases where AM can win on a single component basis. But if you take that system level approach, we've consistently found that it always can win if you deliver a system benefit on the order of magnitude of 15 to 20%. And then I talked a little bit earlier about our vision of cycling the materials, of creating these regional manufacturing hubs that are able to take the previous generation of structures, and with everything we've learned from how those systems have operated out in the field, we're collecting that data, we're building better software, we're building better printers building better materials and then recycling those materials back into the process, we can use primarily secondary materials rather than continuing to exploit and mine these primary materials. We'll be able to do more with much less in the next state. So that's fundamentally our vision as a company, and I think I hope that was helpful to some of you to hear how we think about the problem and where we're pushing AM in terms of cost productivity to achieve that. So thanks for listening.
Thank you, Michael, for the presentation. Thank you. It was indeed a very stimulating keynote. Why I say stimulating? I don't know about the rest of you, but I woke up at the rev of the engine. All right, so at this juncture, I'd like to invite our guests from our VIP Table 1 to join us for a tour of our exhibitions. And as our guests make their move, I'll briefly run through the agenda for today for everyone else. So as mentioned, we'll be touching on 3 different topics today, namely cellular agriculture, sustainable urban solutions, and renewables and environment. Now, each session will consist of 3 to 4 interesting and thought-provoking speakers' presentation and ending off with a panel discussion to further delve into the topic. And for our next immediate topic, we will be touching on cellular agriculture. So the winner of the Startup Innovation Forum 2 days ago, Frontier Bio, the CEO, Eric, where are you? Will be speaking to us about tissue engineering and 3D bioprinting. Our partners will also have exhibition booths outside for everyone to take a look at, so please feel free to visit them. Now I'm sure everyone is running low on their caffeine. I've only had 0 out of my daily 4. Just joking. So we'll now take a 30-minute tea break. We have refreshments prepared for you just right outside. So fuel up and come back at 11 to kickstart the first session for today's seminar. Enjoy a break, and I'll see you soon.